Hello to everyone. In this session, we have to discuss on problems on D'Alembert's ratio test. The first question is test the nature of the series 1 by 2 root 1 plus x square by 3 root 2 plus x raised to 4 by 4 root 3 plus x raised to 6 by 5 root 4. Solution of this problem. Here, first we have to find the nth term of the given series. In the given series, we have to neglect first term because our x starts from in second term. So an is equal to x raised to 2n divided by n plus 2 into square root of n plus 1. So this is our nth term. Then an plus 1. So for an plus 1 we have to replace n by n plus 1 in an. Now we have to consider an plus 1 by an is equal to x raised to 2n plus 2 divided by n plus 3 into root of n plus 2 into n plus 2 root of n plus 1 divided by x raised to 2n. Next, after simplification, an plus 1 by an is equal to x raised to x square by 1 plus 3 by n into square root of 1 plus 2 by n into 1 plus 2 by n into square root of 1 plus 1 by n divided by x raised to 2n. Then we have to apply limit on both sides as n tends to infinity. So we get x square. Here, if x square is less than 1, then by ratio test, summation an converges. If x square is greater than 1, then by D'Alembert's ratio test, summation an diverges. If x square is equal to 1, then D'Alembert's ratio test fails. Now, if x square is equal to 1, then an becomes 1 by n plus 2 into square root of n plus 1. Here bn is equal to, so at numerator we have 1 divided by, at denominator highest degree term of n is n root n. So that is equal to 1 by n raised to 3 by 2. This implies summation bn is convergent because by p series we have n raised to 3 by 2. 3 by 2 is greater than 1. That's why by p series summation bn is convergent. Next, we have to consider an by bn. So that is equal to 1 by n plus 2 into root of n plus 1 into n root n. So at denominator we taken n and root n outside. So we get 1 by 1 plus 2 by n into square root of 1 plus 1 by n. So take limit on both sides as n tends to infinity. So we get 1, that is finite value not is equal to 0. Then by third comparison test, both summation an and summation bn converge or diverge together. Therefore, by first comparison test, summation an is convergent because here summation bn is convergent. So finally, the series is convergent if x less than x square less than or equal to 1, and the series is divergent if x square greater than 1. Next problem. Test the nature of the series x by 2 root 3 plus x square by 3 root 4 plus x cube by 4 root 5 plus x raised to 4 by 5 root 6. Solution. Here first we have to find nth term. The nth term of this series is an is equal to, so in the given series we have x raised to 1, x raised to 2, x raised to 3, so the nth term is x raised to n. At denominator we have 2, 3, 4, 5. Its nth term is n plus 1 into square root. At denominator we have root 3, root 4, root 5, so its nth term is root of 4n minus 1. So then an plus 1. So for an plus 1 we have to replace n by n plus 1 in an. Now we have to consider an plus 1 by an, that is equal to x raised to n plus 1 by n plus 2 into square root of 4n plus 3 into n plus 1 square root of 4n minus 1 divided by x raised to n. Next, so in an plus 1 by an we have, so here we have simplification. So after simplification, an plus 1 by an is equal to x raised to n into x divided by, so at denominator we taken n outside, that is 1 plus 3 by n into square root of 1 plus 2 by n into 1 plus 2 by n square root of 1 plus 1 by n divided by x raised to n. So then we have to apply limit on both sides. So after applying the limit we get x. So if x greater than 1, then by D'Alembert's ratio test summation an converges, and if x greater than 1, then by ratio test summation an is divergent. Next, if x is equal to 1, then D'Alembert's ratio test fails. Now, if x is equal to 1, then an becomes, an is equal to 1 by n plus 1 into square root of 4n minus 1. Then bn is equal to 1 by n root n. So n root n is n raised to 3 by 2 by p series. Here summation bn is convergent. Next, consider an by bn, that is equal to 1 by n plus 1 into square root of 4n minus 1 into n root n. So after simplification we have an by bn is equal to 1 by 1 plus 1 by n into square root of 4 minus 1 by n. So apply limit on both sides as n tends to infinity. So we get 1 by 2. So that is finite value not is equal to 0. So by third comparison test, both summation an and summation bn converge or diverge together. Therefore, by first comparison test, summation an is convergent because here summation bn is convergent. Finally, the series is convergent if x less than or equal to 1, and the series is divergent if x greater than 1. Then the third problem is show that the series 1 plus alpha plus 1 by beta plus 1 plus alpha plus 1 to alpha plus 1 divided by beta plus 1 to beta plus 1 plus alpha plus 1 2 alpha plus 1 3 alpha plus 1 divided by beta plus 1 2 beta plus 1 into 3 beta plus 1. So solution, the nth term of this series is, so alpha plus 1 2 alpha plus 1 up to n alpha plus 1 divided by beta plus 1 2 beta plus 1 up to n beta plus 1. Then an plus 1, for an plus 1 we have to replace n by n plus 1 in an. So now we have to consider an plus 1 by an, we get n plus 1 into alpha plus 1 divided by n plus 1 into beta plus 1. Then apply the limit on both sides as n tends to infinity. So we get, after simplification, we get limit of an plus 1 by an as n tends to infinity is equal to, so limit of alpha plus 1 by n plus 1 divided by beta plus 1 by n plus 1 as n tends to infinity, that is equal to alpha by beta. This is finite quantity, not is equal to 0. So here alpha by beta less than 1, that implies alpha less than beta. Then by ratio test summation an converges if alpha by beta greater than, that implies alpha greater than beta. Then by ratio test summation n is divergent. If alpha by beta is equal to 1, that implies alpha is equal to beta. Then an is equal to 1 and bn is equal to 1. Then summation bn is equal to 1, so that is divergent. Next, consider an by bn, that is equal to 1. So apply limit on both sides. So limit of an by bn as n tends to infinity is equal to 1. This is finite quantity, not is equal to 0. Therefore by third comparison test, both summation an and summation bn are converge or diverge together. And by first comparison test, summation an is divergent. Hence finally the given series is convergent if beta greater than alpha greater than 0, and divergent if alpha greater than or equal to beta greater than 0. So revision, here we have to discuss some problems on D'Alembert's ratio test. So these are the reference books we have to use in this session. Thank you one and all.